Welcome back, Stella. I hope you are doing well. Today we are going to start with integration of fractions or rational functions. When I'm talking rational functions, a rational function is any function of the form f of x on g of x, where g of x is different from 0. This is a rational function. So we are going to see how to integrate fractions or rational functions, things of this form. So let me first show you what we are going to go through. So in this 2.19, we are going to see the first type where we have f prime of x, f prime of x all over f of x. That is, if you notice that a function is of the form, at the numerator you have the derivative of the denominator. We're going to see how to interpret it. We're going to see the type 2 where at the numerator we have f prime of x, f prime of x, f prime of f of x all over f of n, f to the n of f of x. You understand? F to the x, f of x raised to the n. So with n different from 0 and 1. The third type we're going to see, this is the third type. On the third type, there are so many examples, subtypes we're going to see. We're going to see the type a on ax plus b. We're going here, take note that this big A is a real number different from 0. We're going to see the type a on the all over ax plus b raised to the n with n different from 0 and 1. We're going to see the type h of x all over ax plus b dx, where the degree of h of x is greater than or equals to the degree of ax plus b. We're going to see the type h of x on ax plus b, where the degree of h of x is less than the degree of ax plus b. We're going also to see the type a on the ax squared plus bx plus c, where the discriminant is that is b squared minus 4ac is greater than 0. We're going to see also the type a on ax squared plus bx plus c, where the discriminant is equal to 0. Still under this type 3, we're going to see the type a on ax squared plus bx plus c dx, where the discriminant is less than 0. And we're going to end up this type 3 by looking at some integration of rational functions that results in inverse trigonometric functions. You understand? So then we shall proceed to type 4. Type 4, we shall see how to integrate functions of the form 1 all over a plus b sine square x plus c cos square x. That is, if you are asked, for example, to integrate things like 1 all over, let's say, sine square x or 3 sine square x, how are you going to proceed to integrate this? Yes, here we shall end on this type 4 by looking at this last subtype, which is 1 all over a plus b sine x plus c cos x. So basically this type corresponds to, we're going to see how to integrate 1 on sine theta, that is cosec theta. We're going to see how to integrate 1 on cos theta, that is sec theta. So that's basically what we are going to see in this integration of fractions. So we're going to see basically 4 types, and in each of these 4 types there are subtypes in these 4 types. So what I'll advise you in this video is to basically jot down each of these types, because this is integration of fractions and rational functions. So this is how we're going to proceed. We shall start by seeing these 2 types. I'll give the formulas on how to integrate them. Then we shall proceed in the next video. We shall see examples on these 2 types. Yes, we shall solve examples, and I'll also give you assignments. Then we shall proceed to type 3. In this type 3, I'll tackle, I'll always tackle, I'll always do 2 in each video. So I will start by these 2. I will tell you how to integrate this, and in the next video we shall see how we shall practice that in exercises. Then we shall proceed to these 2 other ones. I'll explain and give the procedure on how to integrate them, and we shall see examples. Then we shall proceed to this one, this E and F and G. I shall explain how we are going to integrate them, and in a video we are going to see examples and how to solve them. Then we shall end up with this type, where I'll explain. Here there is not basically if I would say a general formula. We shall just see examples here, some very interesting examples that will help you to be very comfortable when dealing with this type of integrals. Then we shall end up with these 2 other types. These 2 other types, I'll explain these 2 types, give the procedure on how to tackle these 2 types, and in examples we shall practice a lot. So it is at this level that I'm going to show you, because at the beginning I just gave you the formula on how I just said that the integral of sec theta, if you remember well, at the beginning I said that the integral of sec theta was equals to what? Ln of sec theta plus tan theta. We shall prove all this. We shall prove all this. And I said, if I can still remember, the integral of cosec theta was something like ln of, if I can still remember, something like cosec theta minus cot theta. Yes, I think ln of the absolute value of cosec theta minus cot theta. So we shall prove all of that. So it is at this level that we're going to prove it. So, and we shall see more examples, and we'll give you exercises. So this was just a video to basically explain how we're going to proceed in this section, that is 2.19, on the integration of fractions. So see you in the next video, and you can already start doing some researches, yes, on how, on each of these different types. So see you in the next video.